Hello and welcome here to a new tutorial on Industrial Digital Alchemy, and this time I want to present you an Unreal tutorial about the Nanite Microdisplacement you might have heard of. So with the new release of Unreal Engine 5.4.3, Nanite made a major leap into the rendering and ray tracing realm, and I wanted to show you some quick tips how you can pretty much enable Nanite, what you need to take care of with your materials, and how you can maybe enhance it with some decent render settings. I was looking for some tips and tricks on the internet and was not quite happy with the results, so this tutorial is also a big question I will ask at the end. So let's get started. So all in all, we have here the Nanite components, and you can see how this material has a lot of micro displacement and micro detail. And the question first is, how do you enable Nanite? So to make Nanite work, you have to step into several approaches, and one of them is the changing of your default ini from your project settings. And how you do that I will show you now. So first of all, you have to go to the content browser, select any of your materials or texture maps, do a right click and go to show in Explorer. And then you need to go to your config file of your Unreal scene and head over to the ini file of your default engine, and right click and you open with the editor, and you can see here that we have different settings of our project. And the default ini engine text file looks like this. You have here hardware targeting settings, script engine render settings, and you have to go down at the script engine render settings and add this line of code to the end of your stack here. It's pretty much r.nanite.allow tessellation equals 1 and r.nanite.tessellation equals 1. When you have done this, you pretty much close your scene and go back to your project. And in the material slot of your material here, you create a new material like so, and you can call it Nanite test range. And when you go inside, you see that we have here a grayed out displacement parameter. So to activate this, click here on the Nanite material, go to the search bar and enter tessellation and enable tessellation. And then you see that displacement becomes visible for you. So once this is done, you can take your textures into the material, and you can then put them in the according channels like base color and base color, normal in the normal. And here's a little trick of the displacement map, that in this map, especially from Quixel, as I'm using Quixel here, this map here has 3 channels inside of the texture format, and we have to take the red channel for the ambient occlusion, the green channel for our roughness, and we have to take the blue channel for our displacement. So when you now enter displacement anywhere in the field here, you can pretty much enter the magnitude and the strength of your displacement material. So once those settings are done, you hit apply, save. And you can take a simple plane from the creation menu, put that into scene, hit F for focus, and put it on the material. And you have to here enable also Nanite in your plane settings. This is here the Nanite, and we can then see that our material has been applied here to our texture and the plane. So that is one thing, but the other thing is that you can render this also with another technique like the displacement map. You can create in the modeling mode. So here in the modeling mode, let's create a rectangle. Let's put it into focus. Let's make everything as it is. Hit accept. We then go to the mesh and to the model. Hit subdivide, and you can see here that we have a round shape. And what we need to do is hit it to sharp corners. And in our wireframe mode, we now see that we have a little bit of subdivision, but we need a lot more subdivision now. So let's enter here 8. And you can see how dense our grid has become. So hit accept. And then we go to the deform mode, into the displacement. And we can then see that our displacement here is happening. So we take our ground texture, put it on the displacement, and then we can see that we have here a wrong displacement map because it's here in the setting at Perlin noise. We need to set this to texture 2D map, and we can now see that we have the possibility to enter here a displacement map. So in the content drawer, I take my displacement map, but we can see that it's not correct. And as you might remember, in this texture here, we pretty much have displacement in the blue channel. So let's set this to blue channel. And you can see how everything gets displaced in a more or less correct manner. So we have way too high intensity, maybe setting this to 5. So you can see that our stones and rocks are getting displaced here. And then we take a subdivision even further. But you can see that we hit the maximum of our subdivisions. This can be, let's say, this can be changed with the advanced tab. We disable the size warning, enter 5, and we are now able to enter higher subdivisions, which take from machine to machine different times. So now we can see that we have here our displacement method. Hit accept and let the displacement map cook. And now we can see that we have two identical methods to apply Nanite to a grid or mesh or plane or whatever you wish. And here is the little problem I am facing. When rendering this with Pathtracer, what do you guess which side will be rendered correctly? And this is what makes me really interested in the solution, because as you can see, at this plane here, we have a fallback, and the left plane, you see that our displacement is still valid and correct. So I show you again. Now we have here the Nanite path tracing flat. So what you can do is go to the plane and enter the fallback. One second, this is here the fallback target, relative error. Let's change this to 0, because Nanite is creating a mesh that corresponds with the original mesh, but is a bit more of a proxy to adjust the details to the mesh. So let's change this, and you can see here that it's still not working. It's still flat, and this is okay. What you may face also is the fact that the shadows of your path traced nanite is pretty much blobby or scattered or not correct, and therefore there is a little possibility to change that. You can go inside and change this here. So you can change it here to two-sided distance field, and then the shadow should be okay. And we can see now that in our path tracing we have here the difference of our materials. And I'm wondering why this is not rendering correctly and falling back to a flat image. So if anyone has a solution to this, please write me in the comment. You will be mentioned in the next tutorial. Will be highly appreciated. And yeah, that was so far for this Nanite tutorial. I hope you learned something. If you have questions, just ask in the comments below and let me know what you find out and if this was useful for you. Have a great day and take care. See you soon.